Hi guys, today we're going to learn what's called the Pythagorean identity. At the bottom right corner here, you don't have to know this, but I'm showing you where it derives from, and I'll scoot that up so you can see it. It's from the unit circle and the hypotenuse, and one unit the hypotenuse equaling 1, so I'll scoot it up, and it is from the Pythagorean theorem. So anyway, the Pythagorean identity is just sine squared theta plus cosine squared theta equals 1. And from there, you can write this in all different forms. For example, if I want to get sine squared theta by itself, I can subtract cosine squared theta, and I can write it in this form right here. If I want to get cosine squared theta, I can subtract this, subtract it and bring it to the other side, and so it can look like this. So this one form right here, which is called the Pythagorean identity, can be written 3 different ways and still be equivalent. Okay, so there's 3 different ways to write this. Alright, so basically this is just a bunch of math. And I wrote down the steps right here on what you're supposed to do. There's 4 steps. And so what we do here, this is the first example, and this is what your classwork will look like. Step 1 says to find the quadrant. So you still need to know that all seniors turn crazy, but this time it's in radians. So we are given the sine of theta equals 2/3, and we're going to find the cosine of theta. So step 1 says find what quadrant this is going to be in. Well, right here, this tells you what quadrant we're going to be working in. Well, if it's between 0 and pi over 2, that's the same thing in degrees as between 0 and 90 degrees. So I wrote that for you down here, so when you're looking, you can go back and recopy this. Between 0 and pi over 2 is quadrant 1. So I know my final answer is going to be positive. So I'm going to write this on my sheet of paper. And now it says step 2, use the correct formula. Well, I can go ahead and use this formula if I want to, but I want to simplify my work. So since I have the sine of theta, but I'm looking for cosine, I'm going to use this formula right here. I'm looking for cosine, so I'm going to skip right here and use this formula because I'm looking for cosine. So I'm going to write cosine squared theta equals 1 minus, I'm given sine, and I'm going to write 2/3, and I'm going to square it. Okay, so I'm going to have 1 minus 2/3, and I'm going to square it because that's what you do with the formula. You square your 2/3. So now, to finish this up, I know this, I'm just going to keep bringing this down. I'm not going to keep writing it. If I square 2/3, I know that's going to give me 4/9. And in order for me to do subtraction here, I need to have a common denominator. So since I need my common denominator to be 9, I'm just going to change 1 to 9 over 9, because 9 over 9 equals 1. So now I'm going to subtract. So when I subtract 9/9 minus 4/9, I get 5/9, because by the way, that was step 3. So now I'm left with cosine squared theta equals 5/9. Well, you're not done, because that's cosine squared theta. And so I'm looking for cosine of theta. So then what's my last step? Since I just want cosine of theta, I need to square root everything. And remember, when you have a fraction, you need to separate the fraction. So, of course, when I square root the square, I get cosine of theta equals, well, I can't square root 5, so I'm just going to put 5, square root of 5. And since it's an angle, it can't be negative. And then when I square root 9, I get 3. So, well, it can be negative, my bad. But we already, oh my gosh, sorry, there's my little, hopefully I don't make one mistake today. And then, so I go back and I look for my sine, and since it's in quadrant 1, my sine is positive, so there's my answer right here. Can be negative, depends on the quadrant it's in. My bad. Okay, so there's that one. So we're going to do this twice more. So then, alright, so on number 2, I'm looking for cosine, or half cosine, and I want to find sine. So let's find the quadrant it's in. So it's between pi and 3/2 pi. So if you're thinking of degrees, you can think, okay, that pi is 180, 3/2 pi is 270, and of course I wrote it over here for you on the side. So that is quadrant 3 over here. So in quadrant 3, the only thing that's positive is tangent. Remember, all seniors turn crazy? So I know my answer for sine of theta has to be negative. So let's try not to forget that. My sine has to be negative. So then what's going to be the best formula to use here? Well, I'm looking for sine. So I'm going to go up here and I'm going to pick this one because I want to find out what sine is. So I'm going to write here sine squared theta equals, and then I'm going to write 1, be careful on this because it's 1 minus negative 5/8 squared. Now be careful here. You don't want to go double negative because order of operations you want to square first. We're not subtracting first, we're squaring first. So when I square this, I get square this, you get 25/64. And then to have a common denominator, I'm going to change this to 64 over 64. Remember, I'm just going to bring this down, but I'm going to cheat. I'm going to be a little bit lazy here. So then when I subtract 64 minus 25, what do we get there? 39. Let's see. Got to make sure I'm doing this right. Yep, so I get sine squared theta equals 39 over 64. Okay, not done because I have one final step. And my final step here to get the square by itself is to square root both sides. So when I square root 39 and I square root 64, now I know 3 times 13 is 39, but neither one of those is a perfect square. So that's not going to simplify. So we'll get lucky on this one. So I get the sine of theta equals the square root of 39 over the square root of 64 is 8. But let's remember, it's a negative. So there is my answer for this one. There's my answer for this one. Okay, so I have one more to do, and I'm going to tell you it's going to be a doozy, so don't quit watching because we're going to simplify the radical. And if you forget to simplify the radical in your homework, you won't get full credit. So let me bring this up. Okay, so that way you get a good clear picture of this if you're interested. So again, I'm looking for cosine. We're looking at this is between 270 and 360, so it's in quadrant 4. In quadrant 4, right here, oh look, we're looking for cosine, and cosine is positive. So I know my answer is going to be positive. Yippee skippy. So since I'm looking for cosine, I'm going to go cosine squared theta equals 1 minus, again I got a negative, so I'm going to be careful. So now when I square this, I get, remember when you square a negative, it's always a positive, but not that sign. We're squaring this. That's why I put parentheses around it. So I'm get minus 49/81, and then I'm going to change this to 81 over 81. So when I subtract, then what do you get when you subtract? I'm going to cheat. No. 32 81st. So I get cosine squared. Now, when I simplify this by square rooting, I know the denominator is 9. Square root of 32 can be simplified. So I want to think, let's see, can I think of a perfect square for 32? Well, how about 16 times 2? 16 times 2 is 32. So 12 carry 1, 32. So this would be 4. Square root of 16 is 4. So this would be 4 radical 2. And then, so remember it's going to be positive. So my answer would be cosine of theta is 4 square root of 2 over 9. And that's your answer, and that's it. So take a clear shot. So anyway, here's how you get the Pythagorean identity, and hopefully that was good enough. And I think I'm only going to give you 6 problems to do. That's your lesson. Have a good evening.